Yeah, well, all right, so let's start. Welcome to my talk. It's an honor to be here. My name is Ralf Böhme. I'm a member of the Samba team for a bunch of years. I work for SerNet, and this talk is about implementing persistent handles in Samba, telling the story of the journey of like the last 15 months, where I started to look into it and develop some plans how to do this, and tell initially just a recap of what are persistent handles from a higher level perspective. Then I have a funny story of a very genius idea at how we could implement persistent handles in extended attributes. Then comes the long and, not so long anymore, I threw away a few slides, so a little bit shorter, but it's still a boring story about how to implement it properly, persistent handles in Samba with DB rep, whatever it is, more on that later. And at the end, I'll give a summary of the current implementation status. So you can hear me fine. I'm still not sure about the location of the... OK, perfect. Thanks. So a brief recap on what are persistent handles from a really high-level perspective. Persistent handle is kind of a part of a higher-level feature named SMB transparent failover. So another term, what exactly is that? That's one of the key features in SMB 3. And it enables transparent failover of an SMB 3 connection and all its associated state with continuously available shares. The goal is that network or server failures are completely hidden from the application. Like you have a server that goes boom, or you have a network cable that goes cut or something. You have a cluster, and the client switches over, recovers the session, recovers handle state, and it just goes on and doesn't detect any of the error conditions. And the goal is there really to enable storing like server application data, like Hyper-V virtual disk images on SMB3 servers. Continuously available shares, as mentioned in the first one, is, well, it's just like kind of means, yeah, you have a share, and it's an optional feature per share. You can enable or disable it on a Windows server. And on a share where you enable continuous availability, you just essentially enable persistent handles, so the client can then request persistent handles and get them back. So it's just a per share option really to that tells the server whether he grants persistent handles or doesn't. The higher level requirements for a server to support the full stack that is required for transparent failover is one, persistent handle, but there's more. That is a replay detection for state changing operations. You have to do that. And I'm not going into details here in this talk. This is only about the persistent handles, which is already complex enough. So let's go on. Persistent handle semantics. What does it mean? That means that file handle state on a server must be preserved while the client is disconnected across network and server failure. So the client is connected to server, opens a file, server has file handle state, client gets disconnected for some reason, or the server just explodes, then the client comes back later and reconnects, and the server must be able to completely resurvive the file handle state that was there previously. Really surviving a full cluster failure or reboot is not really expected to work, I think, from Microsoft. I had a talk about this with Matthew a few days ago. Though it's supported in Windows, but you don't have to do it. So it's not really required to actually store the persistent file handle state on stable storage. It's actually enough to have it in memory. And the very important part is that now when while a client that has a persistent handle is disconnected from the server, all state change modifications from other clients that might come in while that client is disconnected, they must be blocked. Persistent handles on the wire, that's pretty simple. It's actually just a simple flag on a create where the client just says, hey, this shall be a persistent handle, and then the server does its magic and either grants or doesn't. So I put up some image art to give you maybe a better idea of all that stuff. There was so much text about it. So for example, you have a cluster with 2 nodes with a file, which is maybe kind of virtual hard disk file. And then you have a Hyper-V running SMB3 client connected to the cluster, opens the file successfully. Client and server now have handle state that they use for the write operations, read or write for the I/O. Now, that one goes away. First client goes, oh, what is going on? What did happen? And at that point, while the first client is still trying to figure out, oh, what to do, another client comes in, connects to the cluster, to the still remaining second cluster node. And now that guy wants to access the same file. On the server, the file handle state is still there, and it's red now, as you may notice, so the server is doing some special, oh, I have to be careful here. So what happens is, based on that persistent file handle state, it generally, in most cases, blocks the access to the file. There are exceptions, like for stat opens, or maybe read-only opens, I'm not sure. You do a little bit more research there, more on that later, probably. But generally simplified, you just block access to the file while it's in this disconnected state. So a little later on, the second client comes back, reconnects the session, reconnects the file handle, which is done implicitly by the client. Explicitly by the client. Per file handle, it does the reconnect. Then the second client just retries to open, and this time it succeeds. So that's kind of the, how it works, if you made some graphics out of it. So the takeaway, you store the file handle state on stable clustered storage, which is what Microsoft does, or you can distribute it in memory to other nodes. You just have to make sure that when a client gets disconnected, maybe, and reconnects to the same node or to another node, that the state is there and you can resurvive the handle. You have to update your open code or the create implementation in Windows to check for disconnected persistent handles so you can detect that and block access. Oh yeah, sorry, I forgot to say, if there are any questions in between, just raise your hand and I'll try to answer in between. So there's one.
So how long are you going to keep the state alive, let's say, the client?
Yeah, it's like, how I say, it's configurable, and by default, it's 60 seconds on a Windows server.
There's a request in the client when it creates the persistent handle, what that time should be, and the server
can do its magic. Yeah, the client can do it. The client could request, for example, 1 hour. Then the server has some limits to impose lower values. And then if the client requests a 0 timeout, so with a 0 value, then the server uses some default. So it's a little bit more complicated than that. But I think by default, Windows clients just send a 0, and then the server uses its default value. And I think Windows Server uses 60 seconds for that case. Something like that.
Sounds right. I don't know.
Yeah. I mean, I think the only problem would really be if you implement a lower timeout value than what the client asked for, or you actually send him back the timeout you granted him, and if you then do less than you told him, that would be like, right, you tell him like, oh, I will protect this for 1 hour, but you only do it for 60 seconds, not good.
Is it something like negotiated or the client
It's per request, yes. In the request where the client does the create and request the persistent handle, it either sends some value or it sends 0, which tells the server to use its default. And then the server, yes, maybe imposes an upper limit for client requested values and stuff like that. Yeah,
Sorry,
another question.
to keep going down this rabbit hole. Does that imply the client and server sort of have to agree on what time it is?
Okay.
No, it's just
Yeah.
a time, no.
Sorry?
How long, duration.
I didn't get the question
I
really.
was
Sorry.
wondering if the client and server have to agree on broadly.
You can request it, but what you have granted. It's a nice way to time, it doesn't have
The
anything.
question was, do the clocks on client and server need to be synchronized?
No, it's a relative time. So you ask for, I want 60 seconds.
I mean, they have to agree on the duration of 60 seconds, roughly.
Yes, roughly. That'd be good, yeah. Yeah. Okay, does that answer the question? Yeah. Okay. So yeah, you have to implement replay detection, and that's basically it. So that's simple, right? So let's go on and do that in Samba. And I started to thinking about this maybe 15 months ago, a little bit more than a year, like at Samba XP last year or so. And I had a few assumptions, like support persistent handles only for certain workloads, which is similar to what Microsoft does, which is only like Hyper-V, MS SQL workloads with very minimal metadata overhead. Because for the create requesting persistency, that might kind of be actually a little bit slower persisting the state somewhere. And
How do you know what the workload is at create time?
what do you mean?
What?
No, you don't.
How do you
You
make
don't.
this decision? You get a create.
I didn't. I
Please give me a
don't.
persistent.
Yeah. So the question is, how do I make the decision at create time? The answer is I don't. The decision was made. I don't know, Microsoft management who put up some docs where they say,
It's a client-side decision to set that flag, but you're implementing the server. I'm just trying to understand what
Yeah.
this means.
You can decide.
there's a per share option where you grant it or not. But I still.
That's a separate option, but yes.
No, I'm talking here about like the granting persistent handles in Windows and in Samba, and the implementation will be a lot slower per create. So the question is, can you actually support like home folder sharing workloads or just Office workloads with this persistent handles where each create will be a lot slower? And Microsoft actually says there, well, you can enable that, always enable and use them, but we only really recommend it for these workloads with Hyper-V and MS SQL and stuff like that.
Right.
There's that.
And we use
Explain,
the
right.
tools of like the share property and the client requesting it in the first place. Neither of which we're going to do. It's okay, just keep going. Maybe
All right, all right.
we'll talk about it.
All right, okay,
Okay.
sorry. Yeah, this is really the second point. This is about that, like storing the persistent file handle state in the implementation, what we actually then achieve in the end in our implementation. How long does it take to store this persistent file handle state across the cluster? And which workloads can we support with this? Can we support like, yeah, Office workload or home folder workload with this, or will this just be sucked from a performance perspective? So Microsoft here says, yeah, in theory you can use it, but it will suck, so you better only use it with Hyper-V, MS SQL, where you have rarely have a create, like only once at the beginning, and then the client just does I/O on the handle.
It's not just about storing the handles that causes the slowness, isn't it? If you grant CA on a share, then your write has to be synchronous. You can't just...
Yes. Yes. That's another subtle point with persistent handles. It means, so the question was, not only the create will be slower with when you request a persistent handle, it's also mandated by the spec that writes are synchronous and go directly to storage and are not buffered. And so actually writes will be slower as well, yeah. So, and in Samba, the idea was really also to ignore problems of local access directly on the server or via other protocols. So it will be an SMB only feature. If you have a file with a persistent handle and the client is disconnected, and then on the server you just do an RM, remove file, so yeah. So the implementation ideas I kept moving around in my head was, yeah, maybe in Samba we already have We use databases to store various SMB and FSA layer state. I kept thinking around, maybe there's some way to reuse this for that, and I presented the idea at Samba XP in my talk this year. An update on this is now coming in this talk. And at that time, another idea emerged, actually, which is oh yeah, got it, we do it this way. Store the persistent handle state in extended attributes. And the idea was too good to be true. So here comes now the story of a genius idea. That is storing the persistent handle state in extended attributes in the file server, in the file system, sorry. Like cooking spaghettis in a coffee machine. So the observation was that kind of all operations that can affect the persistent handle state are path-based. So when, for example, when processing a containing create, a containing open, we get the path, we could fetch the extended attribute from the file system, check the persistent file handle state which would be stored there, and then act upon it. When processing a persistent handle reconnect, there's also the path in the request. We could use that to fetch the persistent handle state from the file system. The latter already violates SMB2, the spec that tells you how to do a reconnect of a persistent handle, but I mean, it should be okay at that point, I guess. So, brilliant idea. So what could possibly go wrong here? MSFSA, blah, 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 file rename information. If open file type is directory file, determine whether open file contains open files, specified in section, blah, 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 and so on. What this basically means, renaming a directory requires checking for open files underneath it. And we already cheat there in Samba all the time. Yes, we do. Strict rename is files by default. You could enable it by default. We only check opens in the same process that is doing the rename, but not all the other ones. So by default, we really already cheat there. And I guess we shouldn't cheat on this with persistent handles. So, but to get it right, to really determine if underneath a directory that this client is supposed to rename, wants to rename, and to determine if there's some persistent handle state somewhere in an extended boot somewhere down the tree, that would require a traverse on the file system recursively. So maybe I could think, hey, maybe we could build like a logical extended attribute tree rooted at the shared directory with forward pointers and extend attributes to the next path component and do some scheme of atomic updates on the hierarchical tree, and then like, oh, okay. Nope. This won't do it, so at the top, I have git branch, delete. I have it, still have it somewhere, but I actually got it working. The persistent handle state was stored, and the reconnected work, and blocking other clients did also work, but just the rename, you can't get it working with this. So away with it. Any questions? Oh, great. So now a little bit more boring story about I now did the implementation in Samba properly. That also supports the rename case.
Actually, I have a question.
Yes.
Why didn't you just deny a persistent handle on a directory? Why don't you just treat all directories as non-persistent?
Well, it's not about the persistent handle on a directory. The rename of the directory is just doesn't have to do anything with persistency on the directory. It's just the client wants to on Windows. If you open, if you rename a directory, right? So yeah.
Yeah, I'm still not sure how that's tied up with the persistent handle. So it's just the accounting for implementing that semantic
right.
that made you not want to do it, not the fact that you desperately wanted to provide a persistent directory.
Exactly, yeah.
Okay.
We were cheating there on Samba already, and I think we don't cheat there with persistent handles.
I think the rename, the enumeration when you have to go reconnect is what's going to kill your rename stack.
Yes. Yeah. So can't do it. So we needed another idea. So the other idea was what predates the extended attribute idea is to combine this volatile and persistent DB-Web database models and provide per record persistency semantics by combining those. So dbrep, what is that? Samba uses TDB databases to store various internal bits from the FSA layer, like share modes on files, and from the SMB and from the FSA layer. TDB is a fast key value store, shared memory map hash table with chaining. TDB is not clustered, so for clustering, CityDB was invented, which sits on top and distributes records in a cluster. And then a sane API was needed to abstract away like locking stuff and this non-clustered versus clustered use case. So that was dbrep. It's an API with backends, just TDB for a standalone server or using CityDB for a cluster. So at the dbrep API layer, we implement two distinct modes of operation per database, and it's selected when opening. One is persistent, which enforces transactions, full asset semantics. Problem is, it is really slow. I know this 100 millisecond number here is just, I came up with that figure. I don't know. I think Amitai last year, also another member of the Samba team who works on clustering, he measured it how many stores on a persistent database you get per second, and it's slow. So it's not fast enough to be used for just for every file creation. We use it for other stuff, like storing the machine account password, which is only changed rarely, so it's not a problem. And the other model we have is the so-called volatile model. Doesn't support transactions, that's really just C key atomic updates. But this one is fast, so just a few milliseconds. Orders, 1 or 2 orders will make it faster probably. The problem is this one is ACID without D, which means you have the database on disk, which has lots of precious records. No one is currently has this database open, so you're the first opener that opens it. And with this volatile model, we pass a special flag, which requests, and it's always this way, clear a first, which means the first opener wipes the whole database. This volatile model is used heavily by SMBD to maintain a SMB and FSA layer state. And actually, the cleanup and getting rid of the records is okay for us, because we want to lose that state. For example, if you restart a server without durable or persistent handles, you don't care. You get rid of everything and you start from scratch, and then the clients reconnect and everything is reestablished. So about persistent handles, so what can we do? Combine both. You just have a merge database that opens both. For non-persistent records, you just have unchanged behavior. But you use, for the store, we add a new flag to request persistency. We add a new CDB control push record, which pushes the record to the volatile databases of all nodes. And as a kind of backhaul, the record is stored in the persistent database. And then we have some kind of recovery. So when the first opener opens this combined DB, this time it's again removed, but then the persistent records are restored from the persistent backing store. Actual details are a little bit more complicated than this. Just a high-level overview. So, a few words on the SMB protocol bits next, and how we would implement that. Any questions on the dbrep stuff so far?
So
right.
You have a synchronous write. Your write does not, so you're talking about 100 milliseconds or something for putting in the DB. It's not.
That's the create.
Yeah,
that's the create. Yeah.
But as such, your write is all synchronous write if you're going to have a CA. So it's not going to be any faster than your actual write.
Sorry, I don't get the question.
So you were saying that the delay during the create for the update is the reason why you probably just don't want to update there, isn't it? But if you're enabling CA on the share, your writes are all going to be synchronous.
Yes.
Everything is going to the disk.
Yes.
So you have the same overhead for your I/O. It's not like you're saving anything by just turning on that record update.
Yeah, but that's just So the question is, again, performance of the create slower and synchronous writes slower. That's kind of really a different. This is really the problem is storing the state in DB Web in a database layer for the create. For the writes, we don't do any database access.
No,
So,
yeah. You know, what I'm saying is, you are not getting anything, extra by just not doing that one thing.
No,
Because-
the handle created, the handle itself does not have to be written
Yeah.
to disk. That's the difference.
Yeah. But what I'm saying is, you're not saving much by not storing the handle.
Well, not storing what?
Persisting the handle, that's what I'm saying.
To disk.
Yeah.
To disk. But we do persist it to disk,
Mhm.
the state.
Okay.
We could.
I don't know if this is true. I think what he's trying to say is the writes done through those handles are synchronous. I don't think there is any requirement for that, right? This being
Yes, it is required. So the question is the writes synchronous? Yeah, on persistent handles, writes have to be synchronous.
Isn't it through a different flag in open which says that it has to be synchronous?
No. When you grant a persistent handle, you have to turn that on the server implicitly for writes. All right? So maybe we discuss it a little later on if you have additional questions there, so I can keep moving. All right. So yeah, the protocol bits. Well, we have a bunch of share flags, and we have a global flag. The global flag is the first one here, the global capability persistent handles. Samba will always set that, which means we actually support persistent handles in the cluster case and in the standalone case. It only means the server supports it. Then later when the client connects to a share, there's another option where the server then actually says, okay, I support it for you on this share, so you can actually request and get persistent handles. And that's the share capability continuous availability. In Samba, there will be a new per share option, persistent handles, yes or no, which defaults to no. For there, all right. So then we have another share capability, which is the scale out one, which implies an active cluster. So Windows sets this for the scale out server configuration, and Samba by design is a scale out cluster, so we set that as well. We have another one, capability cluster. Sounds like, hey, you're a cluster, you should set that when you're a cluster. It's a little bit tricky because from the spec at least, it somehow implies you also support witness. I had a discussion with Matthew recently that the client will try to use witness, but if the server doesn't support it, it's okay. So we can set this flag and get away without implementing the witness protocol for now. I think Azure also doesn't support the witness protocol, as Matthew said, and I think more recent Windows clients don't actually don't use witness at all. Don't use witness anymore for faster reconnection to different nodes, for faster connection. You use it still? I think Matthew said you use now something. Don't use witness anymore, something else.
What I said is the newer clients
You're there.
have synchronous redirect ability, so you don't necessarily need to rely on witness for redirection. The protocol itself will handle it, but if you want to handle node failures faster than a TCP timeout and stuff, you still use witness.
Witness, yeah. So at some point we have to tackle that. The problem is, I think we have an implementation of the protocol, the witness protocol itself. The problem is it has a few asynchronous RPC requests, and the RPC server we use in the file server doesn't support asynchronous requests. So, yeah. I mean, we have that in the Active Directory part of Samba, but it seems it's not that easy to just switch over to the other implementation. But yeah, so.
So you're not going to set share cap cluster?
We are going to set it because Azure, for example, I think Matthew told me, also sets it and doesn't support witness. So the client will try witness, but if it fails, no problem.
Okay. I'm not sure there's any reason to set share cap cluster, but I'll think about that.
Yeah, I mean, like on Windows, a failover cluster, for example, we'll set that.
Well, yeah,
And
but what difference does it make to the client?
Yes.
You know, or to the protocol exchange? I don't think there is anything.
yeah, I think there are a few additional places where this is the flag is used in the spec, but I'm not 100% sure
You
yet.
can
I have to look it up. Yeah.
practice any way you like.
Yeah,
but,
yeah.
but I don't think it's going to make any difference.
All right.
I think.
Okay.
It's unimportant. Witness is optional. I agree with that.
Yeah.
Absolutely, 100%.
Okay.
It's a very useful protocol, though. You should consider supporting it.
We do.
Yeah, we actually got it working last week, but we have this issue of integrating that, the asynchronous RV server.
yeah.
Don't we all?
Yeah.
Yeah. So yeah, sometimes we have to go there and do that. Yeah. So. Yeah, persistent handles timeout. This is not about the protocol stuff like we discussed briefly before, just how to implement this in Samba. Because the problem is once you have these persistent records there somewhere, they come back like zombies. So we don't have that automatic cleanup we have with the existing database model. So we have to implement some reliable cleanup for this stuff. So CleanUpD to the rescue. CleanUpDemon is an existing daemon we already have in Samba, which implements some kind of, which takes over some of these tasks of doing when someone crashes or whatever state change on the cluster. There is some kind of fatal or something. It does some cleanup. For example, it's used for triggering byte range locks retries when one child goes away or the client crashes, that other clients that are blocked on the byte, waiting for the byte range lock, then retry and such stuff. So to get all these hooked up together into CleanUpDemon, the SMB service processes on a cluster will ask CDDB to send crash notifications if they crash. CleanUpDemon registers for these server process crash notifications. CleanUpDemon also registers for cluster topology change notification, which means if we have a CDDB Samba cluster with 2 nodes and 1 node goes down, CDDB sends CleanUpDemon a message, hey, something's changed. It's up to you to do something now. And another thing is that on startup, one CleanUpDemon in a cluster is selected as the master cleaner. So all these ends then up in the action CleanUpDemon are triggered by these notifications, or when starting up a cluster, CleanUpDemon becomes the master cleaner. We just then do a traverse on the persistent backing store and check if any of those handles stored there, any clients are disconnected, and we start the scavenging and cleanup of the associated persistent handle. Okay. So far, any other question on that? I mean, it's pretty Samba specific, I guess, so probably not good. So, summary of the implementation status. So for dbrep, I'm currently at 41 patches. Implementing persistent handles on top of that, it's like 90 patches roughly. Diff-start is like 4,500 insertions and 400 deletions. It's not that big, but it's subtle. It's a lot of patches in different areas and hooking it up all together. Persistent handler reconnect works. So, I mean, you can only reconnect if you store it on persistent storage, which works as well, of course. And then persistent handler reconnect works. The cleanup logic works. Protect and disconnect the persistent handles from containing open works. So the basics work. It actually passes the Microsoft protocol test suite, the basic test class they have for persistent handles. So you see it's all green, no red. So that was last week at the Interop Lab that Metzo mentioned where we've been. So the basic stuff works. There's a lot to be done. All patches are really very much work in progress still. Still need to figure out the exact open blocking semantics. For example, stat opens on a disconnected persistent handles, they can pass. I'm not sure about read-only opens. We may think about weakening the strong on-disk persistence we get with this combined dbrep database model for faster performance on the create. We may need to add record versioning for the locking TDB records. That is the database, how we call it, that stores the associated file handle state on disk. Because if you make it persistent and we don't have automatic cleanup anymore at restart, if we ever change that structure, we have a problem. So probably need record versioning. Then for manual cleaning up all that stuff, we may need some kind of cluster generation ID where you, within some command, you can increment the cluster generation ID so all persistent handle state as well is then thrown away when it is found and not used anymore. Byte range logs are not yet persistent, but that is more or less trivial. We probably have to merge our implementation of create, replay, and reconnect. We currently use 2 databases there in the backend, and use also 2 implementations with overlapping functionality. I've started to merge that, but yeah, that's really low-level Samba stuff. So, but it needs to be done. We need to implement correct write time update semantics. That will be funny probably. Currently in Samba, we still implement like the write time update semantics of before Windows 2008 or something. And at that time, Metze found out a few months ago or a few weeks ago that something has changed. If you change for the write time update semantics on Windows compared to earlier versions, we still implement semantics of clients that predate that. And for persistent handles, maybe I guess we really want to make sure that we also have all semantics correct. So, Jeremy.
I was going to say, if the semantics change between 2 Windows versions, did it really matter?
Well, yeah. So
Microsoft didn't detect it.
Yeah. So I repeat the question. So the question is, if the semantics changed between Windows versions, does it really matter? And Tom was trying.
Well, so the canonical answer to that is that MSFSA should discuss this. And if it doesn't, that would be a doc bug and we'll fix it. I think Ralph mentioned the real reason, though. A persistent handle implies a modern client expecting modern behavior. So I would definitely recommend the most modern behavior you could do.
Yeah.
Based on FSA or observation or whatever.
Yeah.
You want to mirror that.
Yeah, because if we get errors there, then you will just give you a tremendous headache trying to figuring out why it fails at some point in the client.
Persistent handle clients, as you mentioned, are Hyper-V and SQL, who are opening disk images and expect them to survive loss of a connection or loss of a server failure, right? If they will corrupt the disk if they lose operations in that window, if they lose ownership in that window. So those are the applications that you really want to focus on for the persistent.
Yeah.
That type of application.
Yes.
Not just Microsoft applications, but that's our example.
Yes.
Our problem.
Right. Yeah. Okay. Jeremy? Oh, okay. Yeah. Then eventually we might also switch to doing this DB rep combining of some database backends, not in the client, but in CDB proper. I had discussions with Amitai, who is the main CDB maintainer in Samba, about how to do this. And I sketched the idea at Samba XP this year, so it doesn't really add much. It's like, does it the CDB server, do we have the client? Maybe it's, yeah, I have to think about that. Then a big item is we have to finally add support for our testing clustered Samba to our Samba CI, which is called AutoBuild. We currently don't have the capability to really run cluster tests in our automatic regression test suite, which sucks. For persistent handles, yeah, that badly. So we really have to add that, and then make use of that with really quite a shitload of tests to really exercise and stress test the whole thing. Yeah, so I have a demo, unfortunately no live demo, but it's recorded, but I'm thinking we actually may have time to show it, yeah, so let's have a jump, Denise. Do I get this big? All right, so this is not a demo of Hyper-V, unfortunately, this is only this is a shell here to a CDB cluster running Samba with patches from like a few months ago. So this is not the newest code, but it worked already at the time when I recorded this demo for Samba XP already. Then this is a Windows 10 client, which is connected to the server. Let's see if it starts, if I press tape. All right, it does. Yeah, so the cluster is, or the Samba cluster is running, yeah, these are LXC containers on my laptop. I'm really starting from scratch, so I'm starting up the LXC containers. Wait till they are running. Connect to one of the nodes. I guess this is probably quite small for the audience in the back, right? So if you want to look at it, you have to come to front. So start CDDB on the cluster. Gives us a few seconds to take another drink of water. Wait till the cluster is healthy. Yeah, I got nervous there. What's going on? Hurry on. Okay, everything okay there, so cluster is up. SMBD also started implicitly. So connect the Windows client. And now just copy a big file to the server. Or the other way. Oh, from the server to the client. All right. Whatever. I throttled the virtual network link between the client and the server. So I actually have enough time to trigger failover. So over there, on the server. Oh yeah, SMB status, checking for open files, and does it say? Oh, it's not there yet. It should be. Where is it? Stop the node. SSH to one of the other nodes still running. Meanwhile, the client there hangs there, trying to reestablish connection. Server is not ready yet. Okay, now on the right side, remaining nodes are okay, so the client should reconnect soonish. There he goes. See, quite a bunch of packets coming in there. All right, copy continues. Hopefully. Yeah. I don't know what I wanted to show there. Well, SMB status is the Samba command where you get print like connected clients and connected files. I don't know.
Node ID.
The node ID? Yeah, maybe. Yeah, so node ID 1, and before it was node ID 0. So yeah, this was really a cluster with 3 nodes, and client was connected to a node 0. I pulled down that node, and the client reconnected to another node, and all that with I/O in progress. And there was a short stall of I/O, and then the client kept on. Yeah, that's it. All right, so far, that's the end. Thank you. Any questions?